Good morning and good afternoon to everyone, depending on where you're joining us from. We still have a few people logging in, so we're going to give them a minute or two to get settled, and then we'll get underway. Okay, I think we're ready to go. Thank you for attending our EU Investor Exposure to Plastics Policies, Resins, Risk, and Pollution webinar. Today's webinar is being presented by Planet Tracker. Planet Tracker is a nonprofit financial think tank aligning capital markets with planetary limits. For those of you not familiar with Planet Tracker, we are a not-for-profit financial think tank. Oops, I already said that. Planet Tracker was launched in 2018 by the founders of Investor Watch and Carbon Tracker Initiative, Mark Campanelli and Nick Robbins. At Planet Tracker, we aim to build upon the growing recognition that the finance community is not yet fully able to accurately quantify environmental risks and integrate environmental data into investment valuations and decision-making. This is partly due to a distinct lack of transparency, effective disclosures, and awareness around company and market dependencies on natural resources, otherwise known as natural capital. It is our belief that if we continue business as usual practices, the degradation, if not outright collapse, of many natural capital resources will happen within most financial professionals' lifetimes, within our lifetimes. Addressing these issues, Planet Tracker focuses on three distinct programs: ocean, food, and land use and materials. Today's presentation sits within our materials program, looking in detail at the plastics industry and how EU policies will affect the future of plastics production and recycling. But before I introduce our distinguished panelists today, first I'd like to cover some housekeeping tips. Today's webinar is being recorded, and the recording will be made available afterwards. During the presentation or following the presentation, we invite you to submit questions or comments in the chat box on your screen. And we will try and address as many of these as possible. If you need to reach me or us afterwards, please contact me via email. I'm always available to answer your inquiries. Finally, we're grateful to you. We have over 125 institutions and individuals in attendance, including analysts, investors, companies, civil society, and NGOs. Today, I'll present the key trends that we perceive in the EU investor exposure to plastics policies, and then ask our distinguished panel to give their views on some of the points raised. Today's panelists are all experts in their respective fields. We're very fortunate to have them join us today. David Clark, he's the Vice President of Amcor, an $18 billion market cap packaging company. Luann Farrell is Managing Consultant at Nexent ECA. She has very deep industry, business strategy, and technical knowledge, along with a master's in chemical engineering from MIT. Suhas Dixit is CEO and founder of AP Chemi, with 13 years leadership experience building out and financing chemical recycling facilities globally, and specifically pyrolysis. Finally, Owen Reynolds with Expon Capital. He's a responsible private equity investor focused on EU opportunities, including specifically packaging and supply chains. Now let's go to the webinar. The EU plastics and resins markets are at a point of transition. The EU long-term demand forecasts are lower than global average. Next, the EU has set numerous policies in place scheduled to occur until 2050, focusing on decreasing the environmental impact of each step in the supply chain. Finally, the EU markets are shifting towards recycled plastics, and prices between recycled and virgin plastics are beginning to decouple. In fact, recent recycled PET or plastic bottle prices at a bale level are double the price of virgin PET. There are too little recycled feedstock, There's not enough recycling infrastructure in place, and competition from both chemical and mechanical recycling is occurring, increasing prices. So let's set the stage. The plastic footprint is specific to each region and country, yet some trends include. In 2014, the per capita use of plastics in the EU was about 50 kilograms. That's about 120 pounds for those of us in the United States. But single-use plastics and primarily, single-use plastic and primarily plastic itself occur in fishing gear, which are driving about 50% of the volume of EU beach waste. Frighteningly, plastic waste is now encrusting land globally. So we are able to see globally from a geological perspective that there's a plastic film encrusting much of the earth. Ingestion of plastic by marine species is chronic. And plastics are about 22% of weight for the EU plastics packaging waste totals on a per capita basis. Technically, plastics, like many other materials we use each day in our lives, have a variety of footprints with a variety of impacts, ranging from global warming to natural land transformation. Thus, the EU has put in place a set of cascading policies to highlight and address these issues at the production level, at the consumption level, where someone like me uses plastics, and at the end of use or end of life level. These policies are beginning to impact supply and demand throughout the plastic supply chain. But before we go into the impacts, let's look first at plastics forecasts for the fast-moving plastics and single-use plastics sector. We're going to look at 3 slides so it's easier to understand, okay? First, thank you to Nexent, ECA, and Luann and your team for providing this data via Bloomberg. In our first slide, we look at production forecasts. Normalized to 2013, we can see that production in the EU is much lower, is growing at a much lower rate than much of the world. The dotted lines are global growth rates till 2035, and the solid line is the EU growth rate of production. Our next 2 slides look at EU consumption forecasts. So if our first slide was production or supply, these next 2 slides are consumption or demand. The difference between production and consumption, or supply and demand, is nominally exports and imports, by the way. When we're assessing EU forecasts of 2035, we can see that much of the growing plastics demand is in extrusion coating, injection and blow molding, and fiber. That's what's highlighted in this slide. And this slide, we see that demand is growing in film. Those are the 4 areas that drive single-use plastic and fast-moving plastic waste, unfortunately, that we all consume each and every day. But we're seeing a decoupling of the market. As the EU policies are scheduled and now in place, we're starting to see that there's not enough recycled polymer to meet that growing demand. Thanks to ICIS, as you can see in the chart here, the annual growth rate to meet EU 2025 policy and 25% recycled polymers is quite high. Simply put, there's not enough plastics being recycled inside the EU to achieve these policy goals. This is why we're beginning to see the decoupling of pricing. On the left, for example, and again, thanks to ICIS, the chemical data provider, we can see that recycled PET and the solid darker green line is twice the price of regular or virgin PET. So recycled plastics as a feedstock are much higher priced in some cases in the EU now, given the policy changes by the EU and corporate policies also. This has resulted in increased competition for recycled polymers. Consumers are pushing corporations to change. Investors are pushing corporations to change also. And corporations are also challenging themselves to change, also in response to their consumers and investors by making deeper recycled plastics commitments. What has happened is we now have increasing demand for recycled content there's not enough content being produced in the EU. And the demand is coming from both mechanical and chemical recycling, which we'll discuss more in the next slides. Before we get to that, there are a set of barriers that we need to discuss. The market barriers include that the European Food Safety Agency has a 95% food content source requirement for recyclability. What that means is, if I'm going to take plastics that's being recycled, that source needs to be 95% from food to then be turned into a plastic to be used again in the food system. At the same time, if we look at mechanical recycling, plastic bottles and other types of recycled products degrade over time. We can only do physical recycling a certain number of times before the resins degrade. Mixed recycling incurs costs and there's significant contamination. If I take a plastic bottle and it's contaminated with some type of organic food, that takes effort and time to clean that bottle at the recycling center. Many of us also engage in wish cycling, where we hope something's recyclable and we put it in the recycling bin. It's nice to have an aspiration like that, but yet that creates a lot of significant problems in the processing and mechanical sorting stage. And currently there's only one country in the EU that is prepared for the EU policy that's coming into law on January 1, 2021, which is an €800 per ton plastic waste levy. So you have regulatory divergence. And there are more barriers. It's very important for us to understand that in the EU, we are missing significant recycling and waste management infrastructure. At the same time, there are impending changes to the Basel Convention in 2021 that will decrease the ability for countries to export plastic waste. So with these laws being enacted, starting January 1, 2021 in the EU, and also in Italy, where there's a €450 tax on plastics that's less than 30% recyclable. We don't have enough infrastructure in place, and infrastructure itself takes 12 to 18 months to build a processing center or sorting center, and another 18 months for testing of packaging to see so that it'd be allowed to be used in the market if it comes from recycled source. Finally, we don't have enough equity, debt, or loan financing. As most large corporations are only interested in offtake agreements because that minimizes their risk, at the same time, most of the chemical recyclers and the mechanical recyclers are generally small, medium enterprises who do not have the ability to self-finance and cannot easily scale unless they receive financing. So like any good story, the drama is shown at the end. This is illustrative only. Right now, according to McKinsey, the EU has a possible $5 billion profit opportunity by 2030 in the chemical recycling sector. the thing is, there's heterogeneous, non-standard, and contaminated supply, as we've discussed. And the EU recycling infrastructure and rates must grow exponentially to begin to have that infrastructure in place for the EU to achieve their policy goals by 2025 and 2030. Right now, there are very few facilities there's not enough mechanical recycling or chemical recycling facilities around each cracker that it would enable for the chemical recycling to grow or for the mechanical recycling to expand. You need about 25 to 50 different chemical recycling facilities, for example, around each cracker to feed that cracker to replace virgin plastic with recyclable plastic materials. So what does this mean? Well, chemical recycling, which is also called advanced recycling, has many different options going forward. There's thermolysis and pyrolysis and gasification, dissolution, enzymatic, and other options. Yet we don't know which one of these processes will win, but we do think that many of the processes will win because they're context specific, and they're also specific to different supply chains. So with that, I'd like to ask some questions of our distinguished audience, distinguished panel. Starting with you, David. What do you think are the economic, consumer, technological, and corporate factors and commitments that plastic containers and packaging companies should include when forecasting their EU and global capital expenditures? So if I'm an EU company, how do I incorporate these policies into my capital expenditures and forecasting?
Yeah, thanks, Gabriel, and hi everyone. I think if you're a consumer goods company, and they would be Amcor's customers, we're making packaging for the consumer brands. You're looking at basically what is the total cost for packaging, not only the materials, but the fees or potential taxes that you were talking about, as well as any requirements that would be needed to work within the specific markets where the products are being sold. And we always have to remind people that, first of all, our customers are buying packaging because they want to make sure that the products that they make are safe and fresh and delivered to consumers through very complex delivery systems, whether it's e-commerce or retail, and ultimately gets to the consumers in a way that is, as I said, safe and they're able to enjoy them when and where they want. So the first consideration is always, will the package perform well? And that's one of the reasons we've seen plastics become so popular as a packaging material. It's lightweight, it's low cost, it has great barrier properties, it keeps products safe, bugs can't eat it, microbes, but then when it gets into the environment, it causes a problem. So the first consideration for the brands is always going to be, am I buying a package that is efficient but effective to do the job that it needs to do? But then as they start looking at, okay, what is this new landscape of regulations and taxes coming in, then they have to look at what's my total cost going to be. Does it make sense to buy recycled content to achieve that 30% target if it's technically possible and avoid a potential tax in some countries that are being discussed now? Are my producer responsibility fees that I'm going to pay in each country for recycling lower with one particular package versus another? And when we start putting these together, it almost becomes like a layer cake of EPR fees, taxes, other potential costs that get added to the cost of the product. We're still in a position right now where for most products, and it varies, of course, depending on the product, the value of the product inside the package and also the environmental footprint of the product inside the package is much larger than the packaging. So it's an important decision, but it's not the critical decision in terms of delivering a product or getting it into the market. But it's becoming much more important. And one of the really interesting things we're seeing is that these sort of taxes and EPR fees now, where they may have been taken care of in the past by a different department in finance or government affairs, are now really being baked into the product marketing, and the product market managers are thinking about these costs as part of the whole consideration of the product. So if they're well designed, they can have a really good impact in terms of moving decision making in the right direction toward more sustainable packaging.
That's really interesting. So Luann, from your perspective, what do you think are the key drivers supporting chemical recycling as a solution for plastics pollution? And also, are you seeing between mechanical and chemical recycling any differences within the greenhouse gas footprint or other environmental footprints or pollution footprints?
Hi, Gabriel. Hello, everybody. As Gabriel mentioned in his presentation, I think the key driver right now is that recycling is depending on mechanical recycling, but it's not producing enough recycled material to meet all of the EU policy and corporate commitments. All the current programs like deposit programs, refund schemes, curbside pickup, they're focused on materials that can be easily recycled mechanically. They look at mostly rigid packaging, not the flexible packaging like films and multi-layer packages. A lot of it is focused on PET and HDPE, and not the other polymers, not the mixed polymers, not the mixed plastics. Chemical recycling includes options which can process all of this mixed waste. And therefore, it's meant to be complementary to mechanical recycling. It's not going to replace it. They're both needed to meet these goals. The goals aren't going to be met with just one solution. And so with chemical recycling, it covers a whole lot of different things. So it can do a single polymer stream. As Gabriel mentioned, PET, after it's mechanically recycled a few times, it starts losing properties, but it can be chemically recycled as many times as it needs to be. Multiple materials can be put together. So right now the focus for PET is, plastic bottles, but there's also, black PET food trays, things like that, which they can be mechanically recycled, but things become downcycled rather than upcycled. But with chemical recycling, you put those things together. It doesn't care about the colorants, the stabilizers, all the other additives, because that's taken care of through the process. The one limitation on most recycling is PVC, but there's not all that much of it actually being in the recycled stream, because it's PVC siding, things like that are long lasting. So you're not going to see that in your curbside pickup. So again, another key driver would be, with the mechanical recycling, a lot of times it's downcycled. You do have bottle to bottle programs for food contact, but the advantage of chemical recycling, as Gabriel mentioned, there's another directive out there for, if it's in food packaging, it has to come from food packaging. But if it comes from chemical recycling, it doesn't matter because it's broken down into starting base components and then re-put back together again. So again, so the driver for chemical recycling, I said, is it can target materials like polystyrene, flexible packaging, things that are considered hard to recycle or impossible to recycle. They're not if you use chemical recycling. But the other issue, as Gabriel said, is the infrastructure. These things need to be collected. Right now, everything's geared towards what can be mechanically recycled or easily and economically recycled. So more has to be collected, and then there'll be more available for both mechanical and chemical recycling.
Yeah, I think that's really the opportunity set here, but also the barrier, the key barrier in the EU is that there's not enough, the facilities aren't in place for chemical recycling collection to occur. And this is where I think, Suhas, you've been working on pyrolysis and chemical and recycling for 13 years. What do you see as opportunities in the EU to expand that infrastructure so that we can meet the 2025 goal, we can meet the 2030 goal? I mean, how do we meet 50% recycling rates by 2030, for example?
Hello, Gabriel. Hi, everybody. That's a very interesting question. So first of all, why do we need chemical recycling? It's the basic fact is that all chemicals that you can produce from crude oil can be produced from plastic waste. all chemicals, whatever petrochemicals that you produce from crude oil can be produced from plastic waste. But plastic waste has a cost of collection. Logistic cost of plastic waste is much higher than logistic cost of crude oil. Unlike crude oil, before you can make chemicals from plastic waste, you need to collect, then shred, then wash the plastic waste to remove contaminants. Wastewater management costs are there. And then after that, you have to do drying of the plastic waste, and then pyrolysis. And after pyrolysis, probably you get oil. And then that oil can replace crude oil uh, in case of most of the petrochemical companies. But some petrochemical companies also require interface technology to clean up that pyrolysis oil, and then some petrochemicals as well as plastics can be produced. So there are some on a rough estimate, there is a viability gap of somewhere around $400 per ton. If you take crude oil and make plastics, it would turn out to be you will escape this cost of $400 per ton of collection of plastic waste, shredding, washing, wastewater management, drying, pyrolysis, cleanup of the oil, and then producing chemicals. So all this cost of plastic chemical recycling is escaped in case you just allow the plastic waste to go for incineration, which has very high footprint, carbon footprint, or you allow the plastics to go to landfill sites. You kind of save around $400 per ton by sending plastic waste to straight landfill or incineration compared to chemical recycling. However, now that all these, and then by sending plastic to landfill, if you do a detailed calculation, somewhere around $1.25 trillion have been saved by not chemically recycling hard to recycle plastics. Mechanical recycling rates are less than 9% right now.
Yeah.
And if you reach 30% recycling rates, unless you have these very strong legislations around EPR, taxes, plastic tax, it would not be possible to kind of integrate chemical recycling in the value chain of circular economy for plastics. Yeah.
Yeah, I mean, it's really interesting. So from where you sit, Owen, there's some clear supply drivers here and some demand drivers, and there's a clear opportunity. So what factors from your perspective would make investing in EU mechanical and EU chemical recycling attractive to impact investors like yourself?
Thanks, Gabriel. And it's actually, just to clarify, we're not like a traditional impact investor. We're a VC investor that invests entirely with like financial returns in mind. So like a lot of people in the audience, we don't have like a clear impact goal, but we invest entirely within the UN Sustainable Development Goals as a way to mitigate these sorts of risks. And so there's a couple things that I want to kind of reframe. One is that we've talked about this within the framework of regulation so far, but the plastics problem is almost broader than that. Like a huge component of the plastic waste stream into oceans is through the toilet. So it'll probably put more pressure onto David's side, for example, on producing products that either are biodegradable or can't be flushed down the toilet or can't end up outside of the waste stream and end up then in the kind of recycling stream that can be better managed. And there's some, just to give some context, and one of the reasons we're worried about it from an investor's perspective is some of the recent research that's come out about plastic impacts, that nanoplastics have been found in passing the blood-brain barrier and the gastrointestinal barrier of marine life. I mean, if that can happen in the oceans, why can't that happen to humans? So I think it's there, whether that is the case or not, the risks are significant, and incorporating those sorts of things isn't a scare tactic, but it's a strategic early pivot that investors need to keep in mind. So from our perspective, what we do is we're digital investors. We're looking for platforms that help to frame and modify either the ecosystem. Out of our current fund, we haven't made any pure investments in that play, but within the UN Sustainable Development Goals, we've invested in companies that are that even if they are using CPG products, are minimizing the amounts of plastics that they're using, looking for low carbon alternatives, offsetting their entire footprint, and then other companies that are helping mitigate climate problems and emissions by either avoiding traditional transportation altogether, as in the e-scooter company. So there's a lot of spaces like that. But the point is, from our side, is that we're looking at really early stage innovation. We're looking at what the next innovative paradigm is going to be. And so for us, for example, one of the things that we've seen more and more is the potential for enzymatic or bacterial or mycological degradation of materials. So I'm hoping that there's more innovation in that area as well that kind of balances out and maybe takes care of at least the chlorine problem, which doesn't seem to be currently addressable at large scale. So PVC, which you mentioned earlier, Luan. So that's one area that I hope to see more innovation from.
That's really interesting. I mean, Luann, do you mind explaining a bit or describing a bit for those of us who are novices what Owen is just talking about when he's saying enzymatic and microbial advanced recycling or chemical recycling?
Okay, I don't know about the enzymatic and microbial. I know those are, obviously I think much smaller scale. And so that's not an area that I've worked in. I've worked in more of the other chemical processes like dissolution, so I don't know if you want to hear more about, because I don't know about the bacterial stuff. So if you want to specifically ask about that.
Yeah, I mean, because the other, for many of our audience today, this list of chemical recycling or advanced recycling options is going to be a bit like looking at the periodic table. Maybe saying, I don't understand any of these words, sometimes me included. So describing where you sort of see the market around these different processes in the EU and where you see different opportunity sets would be very interesting for different types of supply chains too. Okay.
So as Gabriel said, there's a whole, you can see that whole list of things there, and it applies, and certain polymers, plastics can be processed in different ways and recycled in different ways. So if you have a single stream like of PET, like I said, if it's old PET or non-water bottle PETs, that can be done chemically recycled as well, with glycolysis, hydrolysis, a bunch of different processes. And basically what that does is you have a single stream of one polymer, and it gets broken down into its starting components, and then it goes back to a producer to be made into more PET. Polystyrene is the same way. You can take polystyrene, break it down to styrene, if you have a pure stream, and it's turned into more polystyrene. And people are also working on dissolution, where you literally dissolve the plastic. So you have a solvent that pulls out the additives and other pieces, and you have two separate streams, and you can then make that back into another polymer. And most of those processes, Gabriel had asked about the carbon footprint there, those actually have, from various studies, a lower carbon footprint than even mechanical recycling. Then you have the thermal processes, which include pyrolysis and gasification, where you're using heat. Pyrolysis doesn't use any oxygen to break down the polymers. Gasification uses a small amount. Those processes can be used on the mixed plastics, those hard to recycle, impossible end-of-life plastics. So that's, I think, where a lot of the development is going, because you end up with this liquid pyrolysis fuel, as I'm sure Suhas can tell you a lot more about than I can. And the focus of those technologies originally had been to make fuels. But production of fuels, while it's good, it's a new use for the plastic, doesn't count towards recycling goals. So now what people are doing are trying to make naphtha-like products. So it's a different kind of range of carbon atoms in the molecules at the end. And that can then get fed to a naphtha cracker and made into more ethylene and propylene, which can be made into polyethylene and polypropylene, or other chemicals for that matter.
Mhm.
So the focus seems to be on a lot of those, the temperature thermolysis, because you can use mixed plastics. And that's what everyone's saying, well, you know, once you pull out the PET and the HDPE and maybe some polypropylene to be mechanically recycled, you've got all this stuff left, plastic bags and film and juice pouches and all that other kind of stuff. And that can get fed with, you know, preparation to a pyrolysis plant or a gasification plant and broken down into real building block materials.
That's interesting. So, I mean, so Suhas, I think Luann mentions a very key point. In specific to pyrolysis, much of the pyrolysis, the history of pyrolysis, of course, was creating a fuel replacement product, right? And now we're understanding that we can take pyrolysis derived product and turn it again into plastics. Now, there's been if one has followed the news recently in the last 2 weeks over one of the companies out there, and I'm not going to name them, but there's been a conversation on whether it is possible to do chemical recycling on plastics. So from your perspective, I know you've, I think, managed over 30 different facilities. Can you please describe about the ability to actually recycle plastic and turn it into plastic again, as opposed to turn it into pyrolysis fuel and turn it into fuel, please?
Yeah, so as far as, like, just to clarify, most of these 30 different facilities have input capacity of less than 15 tons of plastic per day.
Yeah.
And they produce, say, around 12 tons or lesser quantities of plastic oil or pyrolysis oil per day. Now, in case you have to, which is you can say around 1 kiloton per annum, or 1.5 or 2 kilotons per annum maximum of pyrolysis oil, you know. But if you have to use the same pyrolysis oil, which is currently getting used as fuel in most of the places, even though it is called third generation biofuel because it is derived out of waste, so policies term it as a third generation biofuel. But still, if you have to take it into a refinery and make new plastics out of it, there are two challenges. First is the scale. Usually, the petrochemical players who have crackers would not find it sustainable to take quantities of less than say 10 to 20 kilotons per annum. So if you have to jump from, say, current per plant production capacity of 1 to 2 kilotons per annum to straight away to 10 to 20 kilotons per annum, then you have to straight away scale up the plant capacities from around, say, 10, 15 tons per day to 50 to 100 tons per day of input capacity of plastic. And that's the scale up of the plant size required, so that simply the quantities required by these crackers can be made available. And apart from that, there are two type of petrochemical companies. One type of petrochemical company says that give us the pyrolysis oil as it is. We have all the technology in house to clean up the oil, even like larger than naphtha fraction. Like naphtha fraction is usually around, say, 15 to 30% in pyrolysis oil, but these companies say that give us the full range pyrolysis oil up to 350 to 400 degrees Celsius. We can use that whole pyrolysis oil. We will clean it, convert it into naphtha or other chemicals using the processes that are there in their chemical complex. And there is another kind of companies which have assets installed, as Luan said, to produce plastics or petrochemicals from naphtha only. So then for those companies, somebody else has to take the pyrolysis oil, convert it into naphtha, clean it up, convert it into naphtha, and then they can produce the petrochemicals from it. But as you see, the main challenge is not the availability of technology. It's like, who will take the first scale up risk? Right now,
Yeah,
say
because it's
15 ton per day plant for manufacturing fuels are bankable and project finance is available. But if you have to set up 50 to 100 ton per day single reactor pyrolysis plants for these kind of scaled up capacities, project finance is not available. That also is a major bottleneck.
Yeah, that's what we saw too in our research. The EU has these policies now in place, a cascading set of policies, but the financing is lagging the policies. Sometimes one might suggest it might be the other way around, where financial innovation proceeds or is ahead of policy. Here, policy innovation is ahead of the financing of the facilities. And I think it's also really important to understand that it's not like I can go on to Amazon and order 2 paralysis facilities, have them delivered. And these are not Legos you stack one on top of the other, because even if I have a paralysis facility here where I live, great, I have to have feedstock to come into it, right? And that's always going to be driven by consumer and industrial behavior upstream. So, one thing Dave, where you said, and you're working on, circular economy and natural capital strategy for Amcor, do you see these chemical or advanced recycling options as a part of the circular economy or as part of a natural capital solution? Or maybe we don't yet know, as in some cases we don't have enough information on their life cycle analysis in each facility.
Yeah, I think we're seeing them as part of the solution, Gabrielle. And if you look at it from a circular economy perspective, we always get this idea of sort of the little cartoon loop of materials going around in a circle. And the reality is it's more like this complex web of interacting suppliers and buyers, which is a good thing because a web is going to be much more resilient than a chain where any piece breaks and the whole thing doesn't work. But what we see is, of course, we need to design our products, packaging, so that it works within a recycling system. And we can eliminate some of the materials that we've talked about that are difficult to recycle or just not going to be recyclable. And in fact, many companies are already doing that and committing to do that. So that's going to help clean up this material that's going to be recycled. People have already talked about collection and the need to have consumers participate in the system. When materials are collected, they're sorted into different material streams, not just plastics, but paper, corrugated cardboard, metals, different types of plastic are sorted differently. And we're seeing more and more collection, especially in Europe now, of flexible packaging in the Netherlands and Germany and other places. It's now being collected and recycled in the municipal systems. So once it's collected and sorted, then, and as Luann was saying, it can either go to mechanical recycling or chemical recycling. And we see the big advantage of chemical recycling is if we want to put that material back into packaging again, then we know it's much more likely to meet the food safety criteria, because it's very difficult today in Europe, especially, to get mechanically recycled materials other than PET back into packaging. It's almost non-existent. So if we're going to achieve these targets of 30% recycled content in our packaging, right now, chemical recycling is probably the best pathway there. As Suha said, it's going to be more expensive than virgin resin, but if as a society and industry, we decide that's the right way to go, then we'll have to work out how those costs get absorbed through EPR fees, product costs, whatever it is to make that possible.
So Dave, do you see any, do you have any thoughts on there's a definitional issue here, right? Plastic waste is also a feedstock, and there's recycling versus recovery. And all this is often built into policy or in the law at the regional or at national level. And that creates a very complex sort of web where there's, in some cases, we could say policy divergence, where we have a policy may say this, you need to recycle this, but I literally am unable to recycle it because it's mixed use plastic, and so I guess, if do we need to step back and reconsider some of our definitions of what recyclability and recovery mean and what waste is? Do you have any thoughts on that?
Yeah, I think we do, and I'll be interested to hear some of the other panelists comment on this as well. You're absolutely right. Plastic waste needs to become a feedstock if we're going to have a circular economy. We'll essentially be manufacturing our own raw materials in the future.
Yeah,
they go through the system and they'll come back. So there are standards that are being developed in terms of how do we make that material as recyclable as possible, so that we're not contaminating our own supply chain, in the future. You're absolutely right. Different regulations in different countries right now classify plastic waste or recyclables either as waste or as raw materials. And if they get classified as waste, there may be limitations on how they can be used in the future that need to be rethought as these new technologies come into play. And then, of course, we as much as anybody want to make sure that these materials are going to be safe for whatever intended uses, whether it's for food or pharmaceuticals. And there's a lot of thought that's going to have to go into those regulatory frameworks. But
Yeah, I'm
I
just
think
thinking,
it's all moving pieces at the same time right now, but I'm really optimistic we'll be able to get these to come together.
yeah, I think it's a fascinating moment of transition. I'm just thinking of, like, the 2021 Basel Convention, and if the UK succeeds, some of the people in the government have an aspiration to leave by a Brexit from the EU. Well, the UK, which is a key feedstock source for some recycled containers, milk bottles, into the EU itself, will eliminate some of those that feedstock that the EU depends on to meet its own recyclable goals, and they'll be constrained by the new Basel Convention policy on exporting plastic waste. So we have lots of innovation occurring, and I think it's difficult. I'm just curious, how do you look at this from an investor perspective, Owen? I mean, how would you approach investing in chemical recycling or mechanical recycling, given that there's uncertainty or confusion or not yet clarity in some of the policies? Or are you much more interested in substitute products like seaweed or pulp products that would replace some of the products?
Just because of our kind of philosophy about investing, we probably wouldn't invest in either. Either of the first set, but rather in the kind of next stage innovations and what is in what is actually sustainable. So, right, inputs to products that are biodegradable or otherwise part of the circular economy, because that's where earlier stage financing needs to go to be able to shift the needle in a direction years from now across the industry. So from our earlier stage perspective, that's where we would put it. But certainly looking at where we talked about this as a group beforehand, that the supply chains are so sensitive, and not knowing necessarily where the market impacts and the market effects are going to lie in the next couple of years certainly adds risks. But again, the subsidies mean that there will be earmarked opportunities that are low risk and high reward. And there's also going to be these big shifts that may come asynchronistically and kind of unexpectedly. I mean, COVID, for example, is one big example where I'm sure the demand for plastics was much higher. Are we going to see that impact demand over the next couple of years? And so it just trying to map out the whole ecosystem as it shifts and takes a sharp turn does provide serious risks. But the risks of doing nothing is stranded assets, is the valuation of all of those investments that aren't usable or whose depreciation life cycle isn't going to be fully reimbursed. So there isn't another option, and I think the risk of doing nothing is much higher than the risk of taking well thought out bets in a series of well diversified technologies.
So yeah, so let's ask you. I'm asking another question, Owen. Suhas is sitting there. He has this, this one unit pyrolysis unit, right? He needs to expand it to 10. We need to go from if we go back in the previous slide here, if I can figure that out. Here we go. We need to expand our pyrolysis and chemical recycling units to be around the crackers. How does larger capital that has how does larger capital become interested in these small scale solutions and expanding small scale solutions?
That is the job of early stage funders and early stage companies, is making the unit economics work. And at this point, there's tons of technologies out there that just don't. So for it to get to a place where Suhas would be interested in even applying it, there needs to be either public capital oftentimes to back it to the point where you can prove that it at least isn't going to blow up and kill anybody, and then maybe a little bit of initial capital to prove that the unit economics can work out on a long scale, and then to figure out whether the supply chains will link up today and tomorrow, and whether there's going to be demand or whether there's further regulatory blocks. I mean, to bring back to your original question, though, is interesting. From a personal perspective, I moved away from plastic products in almost every aspect of my life. And that's pretty easy. I'm in Luxembourg, there's policies that make buying milk and yogurt super easy, and most products realistically. But those things need to be taken as a holistic measurement of, are we going to focus plastics for the duration of humanity? And we only have a limited supply of the sources. They will always be needed for really important applications, especially in healthcare, certain food products, and a host of other electrical and engineering uses. And we don't have the resources to sustainably use plastics for frivolous things like yogurt and milk that we could be reserving them for better long-term uses. So it's part of a whole, like in terms of your question on the policy, it needs to be treated as not just the circular economy, but also the minimization economy.
Yeah, that makes really sense. A lot of sense. I mean, Luann, do you see any differences in pricing between polypropylene, polyethylene from a P? I'm sorry. I mean, let me ask the question again. What price range does polyethylene and polypropylene need to be at from a recycled perspective to compete with virgin, given all the upstream costs in converting the polyethylene and polypropylene into a reused product?
That's an interesting question. I mean, at this point, there really isn't enough material in the market to, really gauge that. As Suhas said, there's, yeah, I mean, he came up with the number of about $400. We've recently done an analysis under certain circumstances that had, numbers, between $200 and $400 or $600. So it kind of comes back to, what some of your assumptions are as well. Like the cost of the plastic feedstock. In the US, it ranges from negative, mixed bales to, a couple of cents a pound. In the EU, I'm sure, again, that the price, there's a price range out there. I think to be sustainable, and the wrong word for sustainable, but to be, you have to assume that the price will go up. I think you had a slide on that. There's going to be potentially competition between chemical and mechanical recycling, but just even between chemical recyclers, as you have to build up these number of plants and there's not enough stuff being collected, you have to assume you're going to have to pay for it. If it's free, you've got that saying, like, if something is free, it's too good to be true. It's not going to be something that lasts. So if people are assuming the economics based on the mixed plastic waste is free, that's not a really great economic model. So, we've assumed, at least now, there's at least a minimum cost. There's transportation costs, get it to your site. And it's likely to go up in the future. In broad terms, we looked at the EU and just check my notes here. It seemed like it becomes economically somewhere in the range, it's kind of wide range, between $40 and $65 per barrel for oil price. So, right now, under these conditions, everything's, relatively inexpensive. So it's going to be tough. It does cost more to make the pyrolysis oil than virgin. So under current conditions, although our analysis showed it worked in China, but everything's different in China. But if you get into that range of $40 to $65 per barrel oil, it can make economic sense. And, the other thing to consider is you got the plastic taxes. So, okay, maybe it costs more to produce, but if you avoid paying that tax, that may be able to balance out some of the extra costs.
Yeah. Are you, now this is an open question for the four of you. Do you have any thoughts on how do we mitigate or manage the risk of just exporting plastic trash or trash in general to other locations? I mean, obviously there's the Basel Convention and its amendments that are coming in force shortly. But besides that, exporting of plastics, for example, has been it has been widely discussed in the media. China put out its national sword policy in 2017 to mitigate those risks. How do we make sure that we're not exporting our waste around the world? And on the other hand, creating opportunities for local community sourced waste reduction or reuse recycling facilities throughout the world. Can we do pyrolysis, for example, in small island states? Do you have any thoughts on this?
Yeah, Gabriel, this is Dave. I think we have to focus on what's the problem we're trying to solve. And certainly in both Europe and North America, we were exporting what we thought were recyclable plastics, or what most people thought were recyclable plastics, to countries with poorly managed waste systems who were picking out the easily recyclable materials, and the rest were ending up in the environment. And that's clearly just not acceptable. And I think almost every country, either through Basel or something else, is looking at how do we resolve that. But you brought up another important point was, well, if a certain country has a raw material that could be valuable, plastic milk jugs that are very recyclable, should we be able to move them between the UK and European countries where they will be managed effectively? And I think we have to be careful that we allow free trade and the ability to move products where they can be managed responsibly while keeping them out of the environment by, essentially exporting waste, and finding the right balance in those policies is going to be really important.
Yeah, I agree very much. We're almost at the end of our call today, our webinar. Do each of you want to give each of you like 30 seconds, 45 seconds for some closing thoughts? And Owen, can we start with you, please?
First off, I want to say thanks for hosting this, Gabriel and Planet Tracker. It's a good time to remember exactly how to embed these risks. Let's take EU Green Week as a starting point for the next year. And I tend to use these types of public events as like a moment to reflect on the way that we invest and the way that all investors can holistically try to push capital in as positive a direction as possible. And I know everyone else on the panel is really attuned to this, and finding the best solutions for an industry that has had the full story arc going up and down, and is now in some places being demonized. But there is a more sustainable circle. There are ways to use all the materials. You guys are all way better versed at how to do that. So I'm really looking forward to the next years of finding the most sustainable solutions.
Yeah. Luann, do you have any thoughts?
Oh, yeah, now that I unmuted myself.
Yeah.
It seems to me from an outside perspective as a consultant, if chemical recycling is the answer, which there seems to be, a lot of good points going for it. One of the critical aspect is getting these technologies commercialized at a reasonable scale. Scale up is going to be really important, as Sue has pointed out. So in Europe, what we've seen is there are multiple chemical companies who've teamed up with companies that have thermolysis technology, and they're building plants, but there's going to take 2 to 3 years to get these built. And one single plant is going to be only a small fraction, even if it produces 100% naphtha product that can go into a cracker. One plant is going to, I think our numbers are, depending on the size of the cracker, maybe 1 or 2% of the feedstock. So you need to scale this up. And again, some of these companies, although they may not necessarily want to take a stake in a company, have the resources to scale up. Whereas these smaller companies who develop the technology, they're focused on the technology, the catalyst, how do you get it to work? How do you separate? How do you clean it? How does it operate? You're going to need outside help to get it scaled up. And again, the other thing is to just get the material collected. And also, I think one thing that hasn't been mentioned is I think it's pretty much accepted that everyone's using a mass balance approach to certify what the recycled content is. But I think that's something that has to be kind of finalized and, basically make sure everyone's on the same page.
Yeah, I think it's a really important point. So Suhas, do you have any final thoughts?
Yeah, so there is a requirement of a cross value chain collaboration for solving the complex problem like plastic waste management, you need a cross value chain collaboration between a petrochemical company, petrochemical companies, FMCG companies, packaging companies like Amcor, chemical recycling companies like AP Chemi. Even though we have 50 ton per day single reactor plant technology available, we cannot scale up on our own. Also, a cross value chain collaboration between with material recovery facilities. Also, material recovery facilities are some way influenced by municipal corporations or county councils, so their collaboration is required, and plus collaboration with consumers. So unless this entire cross, and also investors, so until this entire cross value chain collaboration kind of starts vibrating together, it's difficult to find progress at a required rate.
Yeah. And no, David, for you, I'm going to ask you a specific question, if you don't mind. Let's pretend it's 2025 and the EU Single-Use Plastic Directive has been enacted. Where do you think we might be at that point in the EU?
I think it's going to be an interesting time. What we're seeing is not only redesigning the packaging that we've talked about, but also enabling new delivery models, whether it's reuse that Owen alluded to, or finding new ways to deliver new products that minimize the amount of packaging that's being used. I think the directives that are happening in the EU now are really going to spur some innovation in terms of collection infrastructure to get enough materials, and then also the processing technologies that we've been talking about, mechanical or chemical recycling. We're really pushing toward this state where the amount of virgin resin that's needed starts going down because we have more recycled content that we're able to use for the applications where plastics are really the best material. And the part that I'm really interested to watch is what's going to happen with consumer behaviors when we get these new products, new delivery models, new recycling systems. How does that work from a social aspect so that people can participate in these systems and ideally feel more connected with environmental responsibility? So we see this as a huge opportunity rather than a risk, and we're excited about the steps that Europe in particular is taking in terms of creating the financial and regulatory systems to try to accelerate it.
Well, I think you've said it perfectly. With that, I want to thank everybody who's attended. Obviously, you can reach out to me and I can distribute comments and questions or introductions to our panelists. Obviously, we're virtual, so we can't quite give a round of applause to our distinguished panel, but I want to thank all of them. And with that, thank you very much, and thank you EU Green Week, and thank you Planet Tracker. Have a nice day, everybody. Make sure you recycle.